In this video, we're going to talk about applying Sigfigs when we have to do math. So we're going to focus on multiplication and division. When you have numbers that have Sigfigs, how you use them in math has a few different rules. But the basic idea is if you know something is about 10 pounds and you have 100 of them, I'll just say 10 pounds times 100 would look like 1,000 pounds. Well, if you knew your weight very accurately and you had 10.5 pounds times 100 packages, that would be 1,050 pounds. Do you know your package that accurately? Can you indeed know that it is 1,050 pounds, or do you only know that it's about 1,000 pounds? Depending on how many Sigfigs your measurements contain, this changes what answer you can give and how many Sigfigs you can use in that answer when you give it. Let's use the values 1035, and we're going to multiply it by 23.4. If we look at this real quick, how many Sigfigs does each of these have? 2, 3, and 4, there's 3 Sigfigs. 1, 3, and 5, and a 0 in between them, there's 4 Sigfigs. So this has 4 Sigfig and 3 Sigfigs. If we actually just do the math, multiply those two, if you did this on your calculator, you should get something approximately equal to 24,219. So this looks like 24,219. Well, 24,219 has 5 values. It looks like 5 Sigfigs. But the reality is we can't keep that many. When you multiply and divide, your answer has Sigfigs equal to least Sigfigs in math problem. What this means is despite that our calculator indeed gave us 5 values, we don't get to keep them all. I have to go and look up here and say, well, one of my answers wasn't all that accurate. Right? It only had 3 Sigfigs. As a result, when I scale it up, well, there could have been a little extra weight or a little bit less. And as I scaled that up by 1,000 some times, it could throw off my final answer. So I'm not allowed to keep all of these values at the end. I have to round. And so I say, well, I'm only allowed to keep 3 of them. This is going to be the 2, the 4, and I get to keep the next one, but I look at everything after it and I say, hey, is that going to round up or down? Well, 19, well, that's nowhere near like 50. Like, if this next one was a 5, we would round up. If it's less than a 5, we'd round down. 1, even 19, is less than a 5. So this rounds down, and this becomes just 200. In this way, I have 3 Sigfigs, and I still have my 24,000 that I need. Occasionally, I will see students shorten this to 242, that they will drop the decimal places, but you can't get rid of those places. You have to just turn them into zeros. This is still 24,200, not 242. But we got rid of the 19. The idea is we did not know our starting values accurately enough to be certain of that 19. How does that kind of look if we think about the math? We'll do 1035. We'll multiply by 23.5. 1035 by 23.3. Basically, remember that 0.4? Well, the idea is that would have been the one that was estimated. The last decimal spot is always the one that we had to guess. So somebody could have been very slightly off. This means that value could really be a little higher or a little lower. This would have come out 2, 4, 3, 22.5. And the lower end would have been 24115.5. Well, as we look at this, that's quite a bit different then. This would round down to 24,300, and this would have rounded down to 24,100. A very slight change in our estimate would have given us a reasonably different value. So trying to claim that, well, we definitely know those 19 are there, realistically, we're not even certain the 200 is spot on. It could have been a little bit up or a little bit down. And so this is part of the idea of Sigfigs. I cannot, with any reasonableness, tell you that there's definitely 219 on the end. I can tell you, yeah, it's about 24,200. Right? And that's like saying, oh yeah, it's about 110 miles. Like, you're pretty certain at the front part. That last part's a little less certain. It's got a little up and down play. This is why when you multiply and divide, your answer only gets as many sig figs as whatever the least sig figs that went into your math problem. And this doesn't matter how many times you multiply and divide. 15 times 27.3 divided by 1,035 times 17.001. This will come out 6.72648 on my calculator. But if we look at Sigfigs, well, one answer here has one value. One of these values has 4, one of them has 3, and one of them has 2. I only get to keep 2 Sigfigs in my final answer. So I start from the largest, and I just work down the line, 6 and 7, and that's it. So this value would change to 6.7, and the remainder of this definitely rounded down, so it stays 7. If it had been over halfway, I would have rounded up to 6.8, but a 2 is definitely less than 5. So despite all these larger numbers, because that 15 was so low on Sigfigs, my final answer is low on Sigfigs. So whether you multiply or divide, the Sigfigs of your final answer are equal to the Sigfigs of whatever value had the least when you multiplied and divided.